All right, rinse and repeat 4.0, and that this is the fourth example from this section, even though the numbers don't actually connect to it because it looks like it's example 10, which it's clearly not example 10, but that's how tech does the numbering, and that all of the remarks and definitions all get their fancy little numbers. So we're actually going to springboard off of the last example a little bit, in that it won't look anything like the last example, but we're still poking into this idea of trying to get these Turing machines to actually do something. So the first version of wanting to do something is to actually get these little machines to do addition. And the first version of addition is the dumb way of doing addition, which is I'm going to take 4 and I'm going to add 3 and then I have 8, which is the silliest version of addition, but it's also the easiest version to implement onto a Turing machine. In later homeworks, you're actually going to see addition as proper binary addition, where you're going to get all of the cool carrying aspects of here's a binary number, here's another binary number, do the additions, and voila. So I'm going to do the cheap one and then make you guys do the harder one of here's 3 plus 3, it makes 6. So that's exactly what we want to do here, is we are going to try to represent this function of addition via a Turing machine. The first thing we need to do is we're going to have to think about how we're actually going to feed numbers into this machine. And here I'm going to choose the cheesy tally mark option, which is the number 5 is going to be 5 tally marks. The number 3 is going to be 3 tally marks. And you can already see how this is going to be really easy on a Turing machine, is that when I add them together, I'm just going to smush things and then return that back to the user. It's great, it's simplistic, and it's awesome. It's horribly inefficient in terms of space, because if you wanted to add together 10 million plus 800,462, you have to write that many tally marks and then glue them together. So it's horribly inefficient, but it does work. All right, cool. So let's go ahead and chat about how this is going to work. So what's going to happen is that I'm going to be fed in kind of a little tuple. So I'm going to have a 5 and a 3. So what that's going to be pasted onto my tape as is I'm going to say that it's going to come in as 5 tally marks, a little asterisk to kind of represent that it's a change in second string, and then some 1s. You could have gone back to like little octothorpe that we had before. You could have technically put an X between them. I'm just putting some symbol to represent the 2 different strings that are coming in. So it's a function of essentially 2 variables. So we have variable 1, variable 2, separated by some placeholder. You could have done it with this, space or whatever you wanted to. So I chose the convention of just putting an asterisk between those 2 things. So to be consistent with earlier examples, it probably should have been an octothorpe, but whatever. It's some symbol between them. It's very quickly going to go away. So the way that we're going to do the addition now is basically change that little symbol into a 1, which is going to be the idea of gluing them together. But by changing that into a 1, we have too many 1s, so I have to erase the last one. So it's super fast to actually implement into a machine. So fast that I'm not even going to hand draw it. I'm just going to show you what it looks like, and then we're going to jump into the TuringMachine.io version of it so we can play with addition and click through a whole bunch of things. So the way that this is going to work is that when I read through that first kind of number, I'm just going to jump over all the 1s, and I'm going to find the star. Once I find the star, I turn the star into a 1, and then I'm going to go looking for the end, and then I'm going to click 1 back to delete, and that's it. So it's remarkably efficient in design, remarkably inefficient in actual execution, in that it's a whole bunch of clicks, click, 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 and it becomes pretty awful there. But in the actual machine, it's super nice and tidy. So if we have, 1, 1, star, 1, 1, 1, so this would be 2 plus 3, which is fancy. It's going to jump over all of those 1s, and it's eventually going to turn that star into a 1. Well, then we have too many 1s, so it is going to ultimately erase the last 1 and then leave that on my tape. So that's what's happening here. Find the star, turn the star into a 1, find the end, and then delete the last 1, which is what that little process is then going to do. And that's it. It's got 4 states. It's only got 2 little loops on it. Everything else is pretty awesome about it. So let's jump into the little world and we can see this thing in action. So hooray, you're going to see 4 states again. How exciting. All right, so we have addition of, what do I have? 5 plus 3. So if I load this thing up, well, it's going to jump over all the 1s, turn the star into a 1, run to the end, delete the last 1, and voila, I now have this tape that has 8 symbols on it, so 8 tally marks. Hooray. I guess what was it? It was 5 and 3, and boom, now it's got 8 symbols on it. Some things to check, to always be aware of, just kind of some of the weird edge cases. If I wanted to do like 3 plus 0, well, 0 would come in as no tally marks. So I want to make sure that this thing works, which it does. So jump over all the ones, turn the asterisk into a 1, delete the last character. The last character here actually ends up being the one that was pasted from the asterisk, but it still works out. Other things to consider, I guess if you want to see that again. So 1, 1, 1, change the 1 into an asterisk, find the end, delete the last one. Great. Other things to then consider is if I did the 0 plus 3 option, if I loaded that up, I would seek star and I'd find the star right away. So that star gets turned into a 1. I run to the end, I delete the last one. And again, I'm left with a tape that has 3 1s on it, which is then what the sum of 0 and 3 happens to be. As I mentioned, it is awful if you wanted to try to like add, I don't know, whatever you want, this many ones with this many ones. So if you load that machine up, obviously you're gonna have to like march all the way through, change that, march all the way through, and then come back. It's horribly awful in terms of wasted space on this tape. So as I kind of push this a little bit farther, we will see more efficient ways, namely how to actually do binary addition on a Turing machine. It's one of the kind of classic textbook examples of doing all the carrying and the swapping and all of the greatnesses that is binary addition. And it keeps things really tidy in that I just get all these kind of dancing back and forth. It's a cool little machine to watch in action. It's way more interesting than go across the ones, change the star into a 1, go across the ones, delete. But it's a nice one to end on so that you can see kind of the variety of, some of them are really easy, some of them are not so easy, and then you get to go crazy with them.